Okay, so in this video clip, I'm going to run through how you would run Matlab in Google Colab. Matlab is a fairly significant piece of software used for numerical computing. It's popular with mathematicians, statisticians, and people in engineering, in finance, and so on. And if you look around, you will see quite a significant amount of files available. I was just taking a look here at lattices for option pricing. And you know, if you run through the different files, you can see quite a substantial amount of content available. Now, to make it available, Matlab needs to be made available in the Google Colab environment. Normally, the script in Google Colab is Python, but you can implement R, you can implement C++ and other languages. In fact, the installation, I just installed this a moment ago and then I deleted and came back. It takes about 1.5 minutes typically. A lot of files are downloaded in zip form, have to be extracted and then installed. So it's not as quick and streamlined as it would appear here in my execution of the code. Anyway, it's loaded in. So basically, once we've installed the Octave, we have to develop then a file where we declare a function. So basically, we could set out X here using a very simple, minimalist Matlab bit of syntax. We set 3 being equal to X, 2 being equal to Y, and then we add both. So that's the function, if you like, and then we display out. And if we run that, of course, we should get 5. Now, when the file is being read in, it's not immediately. We don't see the output here. To see what's going on, if we go into the content folder, right, we notice that a file has been written in to the content folder. Okay, so maybe to see this here, we'll go into the content folder. Content folder, we open, and then you can see that add.m, this file is appearing here. So if I double click on that, you can see whatever was written here appears here in the content folder. And then to execute it, we have to use some more syntax, exclamation Octave minus W and then add M, right? So when we run that, we get the estimation of the 3 and the 2, okay? And again, because my field is related to finance, we would like to do something similar here for option pricing. I take the Black Scholes model and apply just a basic formula. Now, I took this from Espen Hoag's portal, and it just has some basic Matlab syntax. So basically, estimate a D1, a D2, and then estimate the value of European call option, where S is the stock price, X is the exercise, and the option, R is the risk-free rate, V is the volatility of the annualized return, and T is the maturity in the option. And we're not going to, we don't need this here. We can remove that. Let's just write that in. It should appear here. Once we write the file, we can refresh. And it's now BSM now appears. And then to output, again, we follow the syntax we have here, but just instead of add.m, we put in bs.m. When we execute that, we should get a value of 1045. Okay, so we get the parameter inputs, and then the Black Scholes value is 1045, and I verified that then from previous estimations that I would have done. One of the interesting things here is that there is quite a bit of Matlab code for different types of option pricing. I've went on here to mathworks.com, and again, there's a whole array of functions that are written. You can take those and implement that for the Black Scholes model. And I had an interest here in the binomial model, and so Cox-Ross-Rubinstein, CRR, and then there's a trinomial model for Boyle and KR. And I, again, using the same parameter values with 100 steps in the tree for a trinomial model, I took elements of that code and put them together and then estimated. Now I have to check the values here, but so we've written in basically what I've done here. I've taken Boyle, trinomial. The link is I will leave here. I've taken a few elements of different bits of code on that portal, right? The mathworks portal. I've incorporated together, and then I execute. So if I run this code, it's overwriting try-ball, writing it should be here. So it's now here. And then to output, again, it's the same format as before. We use this syntax and then the name of the file we've written into the content folder. Let's take a look at that. With the parameter values I've put in for this, the valuation here is going to be European option, as it turns out. So the same parameter values as before. We should be getting 1045. Now it's only 100 steps, so it's not that accurate. If I run that and then run this snippet of code, right, I get 1045 too. This is an approximation, right? Number times steps. Really, to get through, I should be up close to 10,000 steps probably, right, to be happy. But it's relatively accurate. And then there was another model here. This the model below. Let me just see another trinomial model, KR, Kitchen, Richten, Kamrad Richten, 1991. A fairly significant trinomial model, referenced quite a bit in the literature. I just borrowed the code here. The original author, let's give him some credit, is Chen Boe, and Boe Chen, PhD from the University College London. So he must have wrote up the script for mathworks. I've again done a few, I've combined different snippets of code here from that portal. I'm going to use the same parameter values, execute, 100 steps. It should appear here in a moment. If we close and open again, okay, now it's there, so it's written in. And using the same parameter values, I'm getting 1044 tree with 100 steps. It looks okay, right? So I'm not going to, I'm quite confident in the code written by Chen, right? Boe Chen, right? But I'm not confident in how I piece together the different snippets of code into Colab. So it looks okay, but I would need to do additional checks on the code just to see, to verify that the result is kosher. Okay, now a little bit more about Matlab. It's not a completely new language. It's a numerical programming language. It generally is available for free if you're affiliated to a university or an educational institution. Otherwise, you have to use commercial license. It's got a very interesting history. It looks like it was programmed in C, but it's what I like in particular about the language is that you have a lot of solutions, particularly in the area of finance, right? So there's a lot of code in there relating to finance and so on. And that's what makes it stand out a little bit. If you look at the TIOBE index, right, you know, the big ones here, again, this is July 2021. Python, Java, C, C++, C Sharp, Visual Basic. So they historically have been the important ones here. And let's just see if I can get that back. The rankings. Okay, so you can see C, Java, Python, C++, C Sharp, Visual Basic, JavaScript. They're the big languages. Or, of course, 19th placed here, 19th is Matlab. It's gone down a little bit. Again, they shift around quite a bit, but it's quite a significant language, given that it is that it comes with a license, right? So obviously people are making use of the language, and again, importantly for us here, we can set it up and run it in Google Colab, where no license, as far as I'm aware, no license here was required, right? So you can run Matlab script in Google Colab, and it's just using basically this syntax here. Exclamation apt install Octave, and then write file with the name of the file. It appears here in the content folder, and then to output the results, we use this exclamation Octave, a minus sign W, and then the name of the relevant file. And the ones I stand over are the Black Scholes model, which is correct. So this MATLAB code was executed, and we get the estimation here. So, okay, let's leave it there.